Buildings began as shelter from the elements, with simple forms of construction. This allowed humans to adapt themselves to a wide variety of climates and become a global species. With a good understanding of the local climate, local materials were identified and construction skills were developed as the need for better shelter grew. Building design, building materials, and construction techniques evolved at a slow pace. Gradually, more durable structures began to appear when people began to stay in one place for long periods. The first shelters were dwellings. Then food storage and ceremony buildings were built. Some structures began to have a symbolic as well as functional value, marking the beginning of the distinction between architecture and building. Construction materials and techniques developed into more solid forms of stone and baked clay. This form of wall construction continued in Europe for several thousand years. Because of their massive size, these walls were exceptionally strong and durable, and provided greater protection, especially from enemies. Some of the world's most significant architectural achievements have been built with masonry. Through civilization, architects and builders have chosen masonry for its diversity, versatility, and durability. Where the climate was colder and masonry not as readily available, houses of logs with clay infill or earth toppings were built for their greater insulating properties. How joinery came to be used in building construction is not known, but builders in all of the temperate regions relied on timber frame construction as wood was the most available building material. The oldest timber frame building in the world is reported to be a temple in Japan built in 607, while in the UK, this 11th century church still stands today. On-site timber framing remained the most common method of wood construction until the Industrial Revolution, when it was replaced by prefabrication, a system which uses dimensional timber and metal nails. In some parts of the world, lightweight timber construction is still a popular method of building. Where the construction material has low porosity, such as concrete or dense stone, the wall relies on the material to keep the water out. However, any cracks in the wall can allow rain penetration. Brick masonry walls use relatively porous material, relying on mass to absorb and re-release moisture in more favorable conditions. This works well provided the wall is thick enough. However, over time, as the trend for thinner and lighter wall constructions grew, rain penetration proved to be problematic. The cavity wall evolved in response to this need. A cavity wall is defined as a construction of brick or masonry units laid with a clear space between two layers. The layers are tied together with metal ties. The cavity prevents water from reaching the inner layer. While cavity walls started to be used in the early 1800s, it was not until 100 years later that they became more popular. Drainage holes were added in the early 1900s, which also acted as small vents. However, this is limited and is not enough to be classed as a rain screen. Cavity walls soon became recognized as an accepted way to build. The original cavity space was small and grew over time as insulation was added. With new regulations, the cavities are becoming wider. Specialization and mass production, the hallmarks of the Industrial Revolution, were introduced into the building industry during the 19th century, leading to the rapid development of new materials and techniques. Until then, the external wall acted as the main load-bearing structure and protection to the interior. What happened then was that the main structure and the outer skin were now considered separately. In the West, the traditional massive wall gave way to this skeletal structural system. Cast iron structural frameworks with load-bearing infill walls were being used in England by the turn of the 19th century. Flexible frameworks of cast iron and later the much stronger wrought iron soon appeared in English train stations, some of which are still in use today. The first examples of prefabricated buildings, where the skin is separate from the structure, occurred in the mid-1800s. The first multi-story building with non-loading bearing walls, where the iron frame carried the full building weight, came about in 1865 in Paris. The next step in the development of buildings was the birth of the skyscraper in 1884. Chicago led the way with iron frame structures carrying the weight of the facade and the first all-steel frame building. By 1895, these towers contained many of the technical components of the modern high-rise tower: curtain walls and elevators. The advent of steel skeletons and later reinforced concrete frames led to the development of thinner building skins consisting of lightweight facade panels and large areas of window. This reduced the weight of the wall that the frame had to carry. This form of building rapidly became universal and was promoted by the vision of architects such as Le Corbusier, Mies van der Rohe and the Bauhaus School. Over the same time period, expectations for comfort and durability rose. However, these changes in building structure, materials, and methods of assembly did not always result in an improvement in durability or in better control of the interior environment. Buildings with steel facades and large areas of glass require powerful air conditioning to address the comfort of the occupants, especially the temperature changes caused by solar gain. Curtain walling is a sealed facade lightweight building system. Normally, a curtain wall comprises of a vertical metal frame with glass panels, which supports no load other than its own weight and the forces which act upon it. As well as metal frame curtain walls, precast concrete panels are also used. There are a few different types of curtain walls with one common factor: that the outer skin relies on sealants to prevent moisture infiltration. The joints in the outer skin are sealed up. If this seal breaks down, water will enter the building as there are no secondary means of defense. The stick system, which is assembled on site, is the most common form and is used on low to mid-rise buildings. The vertical members are fixed to the floor slab and then connected with horizontal transoms. Into this frame will fit the glazing or panels. The unitized system, which is more common on high-rise buildings, consists of pre-assembled, narrow, story-high units fixed via brackets to the concrete floors. Similarly, the panelized system is also prefabricated, but the panels are larger and connect back to the structural columns or the floor slab. This system is popular for precast concrete panels. While most systems run with a vertical pattern, the spandrel system has a horizontal look. This system consists of long runs of windows. The spandrel panels are connected to the floor slab and span between the windows. Structural glazing are large sheets of strong glass without any frame, which is connected directly to the primary building frame or held with special bolted connectors. Throughout time, the history of building is marked by a number of trends: durability, the quest for ever great height and span, and control over the interior environment. Today's latest trend is the reduction in the amount of energy available to a building, both in the construction phase and the operation of the building. In recent years, the field of building science and a growing awareness of the interaction between the interior and the exterior environments has led to improvements in building performance. The need to conserve global energy resources also requires more efficient buildings. Spurred on by this, buildings in the industrialized world are now better insulated, more airtight, and more responsive to the sun, the climate, and the local microclimate, essentially a return to the principles of early buildings. It is becoming clear that building designers must understand how the building skin performs in order to design better buildings. To address this evolution towards better buildings, the ETEX group of companies promotes RAINSCREEN or the ventilated facade method of construction. RAINSCREEN is the latest evolution which combines the knowledge of the past and the techniques of today. This had led to the better understanding and increased use of RAINSCREEN or ventilated facades as a method of enclosing the building. It addresses the needs of the building and in particular the comfort and health of the occupants.